Hello everyone, in this video I will be explaining the problem Pythagorean distance nodes in a tree. So this is an easy problem only, don't worry. The problem looks, reading looks scary, but it is very easy. If you know the BFS traversal, so it is very easy. Even if you don't know, don't worry, I'll be telling you how to traverse in the BFS. So this problem was asked in Leetcode contest, weekly contest 486. So you're given an integer n and an undirected tree with n nodes number from 0 to n minus 1. So basically we have a graph which has n nodes and the nodes are numbered from 0 to n minus 1. The tree is represented by 2D edges, okay, the of length n minus 1. The tree is represented with 2D array edges of length n minus 1. Okay, so we have edges and its length is n minus 1. The reason being, since it is a tree, undirected tree, so it has n minus n edges, that's why. So where edges of I is basically UIVI indicates an undirected edge between node U and node V. So you are also given three distinct target nodes x, y and z. For any node U in the tree, let dx be the distance from U to node x, let dy be the distance from node U to node y, let dz be the distance from node U to node z. The node U is called special if three distances form a Pythagorean triplet. Okay, so got it. So return an integer denoting the number of special nodes in the tree. Okay, so they're asking return an integer denoting number of special nodes in the tree. Okay, so a Pythagorean triplet consists of three integers a, b and c, which when sorted in ascending order satisfies a square plus b square is equal to c square. Okay, this is cool. Like they've said what is Pythagorean triplet. So from the school days also we know already. So but yeah, the sorting is actually good. I'll tell you, like I was thinking of comparing all the combinations, like a square is equal to b square plus c square, b square is equal to a square plus c square, and c square is equal to a square plus b square. But this sorting in the whatever they have said, it is a valid one. So we need just one comparison. Don't worry what I'm telling you right now. I'll tell you on the board also. So the distance between two nodes in a tree is the number of edges on the unique path between them. Got it. So we have four nodes and three edges, and we have xyz as xyz and as 1 2 3. So yeah, let me go to the board and explain you what they're saying. So in the problem, your number of nodes are 4 and edges are 0 to 1, 0 to 2, 0 to 3. XYZ are 1 to 3. So let's draw a graph. We have 1, sorry, we have 0, we have 1, we have 2, and we have 3. So we have edge between 0 and 1, so let's draw. We have edge between 0 and 2, let's draw. We have edge between 0 and 3, let's draw. So as you can see, like we have 4 nodes 1 2 3 4. So since this graph is a tree, so by definition of tree we will have n minus 1 edges, like 3 edges 1 2 and 3. The reason being is that if you try to insert one more edge, it is going to be cyclic, but these things I'll not be discussing. So let's try to focus on the problem. So they have said your x is this, your y is this, your z is this. Now from all nodes, now you're at node, let's say 0. So what is the distance between x and node 1, dx let me call. From node 0 its distance is 1, and distance is given as number of edges between them. How many edges are there? We have one edge, so dx is 1. What about dy? Distance between this particular node, for the node we are considering, and the node y, so it is also 1, and dz also is 1. So this is if you try to sort this, it is like 1 1 1 only, and if you take 1 square plus 1 square is not equals to 1 square. Okay, in the problem statement they have said a square plus b square is equal to c square, has to be um, the condition, but here it is not, because 1 plus 1 is 2 and here it is 1. 2 is not equals to 1. So from this node we are not getting any special triplet, right? Pythagorean triplet. Let's try to consider this node. If we consider this, from node 1 to distance x is 0. Okay, since it is same node, we don't have any edge, so it is 0. And to node y, if you see how many edges are there, 1 and 2, so distance is 2. What about dz? It is also 1 and 2. Now try to sort it. If you sort, your a, let's take 0, b is going to be 2, c is going to be 2. Now this condition will hold good, because 0 square is 0 only, 2 square is equal to 2 square, which means we have got one special triplet. Now we have considered this node, we have considered this node. Now let's try to consider this. If you consider this, so your dx is going to be 2 right now, because from this node your distance to x is 1 2. Your dy is going to be, from this node your distance to y is going to be 0, since it is same only. dz is going to be distance from this node to the node z, which is 2 1 2. So again sort it, like a will be 0, b will be 2, c will be 2. Same thing it is, so it is also a special triplet. Now let's take from this node. From this node as distance is again 2. Node y distance is also 2 1 2. Node z distance is 0, and again it is 0 to 2 only, so it is forming a triplet. So in this case you have 3 special triplets, so your answer is going to be 3. Okay. I think you have understood the problem statement, what they're asking. So basically what you're trying to do is you have to consider every node. From every node you take distance x, distance y, distance z. Whatever distance is there, try to make a Pythagorean triplet. Okay. So now how do you solve this? How do you solve this is the question. So as you have seen, since we are considering all the nodes, right, like let's say 4 nodes are there, so you are considering all the nodes. So and they've given x, y and z. So what I'll be doing is I will find from node x the distance to all other nodes, right? Like 4 nodes we have, so I'll take a vector, and this column let me denote it as x, y and z. This is my vector, and this is node 0, node 1, node 2, node 3. Since node are 4 and it is from 0 to n minus 1. Now from node 0 to distance x, to the x node, what is the distance? We have 1. From node 0 to the node y, what is distance? It is 1. So you are understanding this, right? So let me call this as a distance vector. Okay, its size will be n cross 3. Why 3? Because we have x, y, z. Okay. From node 0 to node z, what is distance? 1. From node 1 to distance x, node u, what is distance? 0. From 1 to 1 it is 0. From node 1 to distance node y is distance 2. From node 1 to node z is 2. Similarly, um, from node 3 to node x, what is distance? 2. From node 3 to node y, what is distance? It is 2. From node 3 to node z, distance is 0. So we will try to make this distance vector. When you have this distance vector, what you can do is, which means now we'll try to take one by one all these triplets. Okay, we'll take all these triplets and try to form the Pythagoras triplet. A square plus b square is equal to c square. If it is there, then it is a special one, right? We can increase the special. So now how do you find this? It's an easy method. I think you guys know about BFS, breadth first search. What we can do is, in order to find this distance, we will make sure this is my source node. We'll start from x and we'll do a BFS to every other node. So from x to x, distance will be 0. From x to x, which is like node 0 only in this case. Sorry, it is node 1, not 0. Yeah. So distance is 0. Okay. Next element we will be taking, its distance is 1. Now if you move forward, this distance are 2. So from x to node 1, distance is 0. From x to one more am I missing? I think from 2 also I would have checked it, so you can take from 2 also. From 2 to node 0, distance is 1. Sorry, from 2 to node x, distance is 2. And from 2 to from y to 2, distance is 0. And from 2 to z, distance is 2. You can take this. Okay, so as I was saying, you'll have to do BFS. When you do BFS, you'll get your source node will be x. From x, you are finding the distance to all other nodes. It is x, you are finding distance to all other nodes. From x to 1, distance is 0. From x to 0, distance is 1. From x to 2, distance is 2. From x to 3, distance is 2. So we have got it. Similarly, do BFS considering node y and then node z. If you do this, you will get this vector and you can easily find the number of special triplets. Let's try to code it up. So it's a bulky code, so I'll be writing in front of you one more time. So this edge is u comma v. So in order to make sure we don't need to travel in the edge in O of n, so we'll create an adjacency list. Okay, and its size will be n. I think you guys know how to create adjacency list. So basically I'm iterating through these edges, and what I'll do is I'll take int u as edge of 0, int v as edge of 1. Okay, now in this adjacency list of u, I'll push back edge of v. Sorry, not edge of v, it is just v. And since it is unordered, undirected, so I'll be pushing adjacency of v into a u. Okay, just to make sure we are traveling in O of 1, like neighboring nodes we are finding O of 1, so we are creating adjacency list. Now we have created adjacency list. Now we'll have to find the distance vector, right? Your distance vector row will be n and column is going to be of size 3 because xyz as I showed in the board. Now we'll have to find this. Okay, so what we'll do is we'll call BFS. We'll pass X, we will pass this adjacency list, we'll pass this distance vector, we'll pass X, Y, Z. Once we'll have to call for X, other time for Y, and the other time for Z. Okay, now let's move forward. We'll write the BFS function, or else first let's think of, we have found the distance, all the distances. What we can do is now we can travel through this distance vector. We'll take one vector, we'll call D, and it is going to be distance of I. Like one row, it is triplet we are taking. We'll sort this. The reason why I'm sorting, as I said, we will be doing this thing, a square plus b square is equal to c square. So when we sort this, the bigger number will be at this position. So in the Pythagoras triplet also, if you take like pairs 3, 4, 5, so the bigger one will be at the alone side and the smaller one will be together. So that's the reason I'm taking. Now we'll have to check if d of 0 into d of 0 plus d of 1 into d of 1, if it is equals to d of 2 into d of 2, which means a square plus b square is equal to c square, then take one special variable. Your special is going to be increased by 1. At the end we'll have to return this special. Okay, now let's write the BFS function. First thing first, we're passing the source. Okay, x, y, z, whatever we have written, it is like a source. Now we are passing adjacency list. We are passing this distance vector wherein we'll have the distance values. Now we are passing x, we are passing y, we are passing z. Now we take n as adjacency dot size. We have got how many elements are there. Okay, now we'll take one visited vector, typical BFS traversal I am doing right now. So its size will be n and all values are initially false. Now we'll have to take one q, and I'll be taking it as pair because in the q, first element will be the distance, which is 0. Like from the source node, uh, from the source node to the source node distance is 0, right? Like like let's say we're traveling from x is equal to 1. Okay, so when we're traveling from 1, so the distance between like 1 and x is node 1 and x is 0. That's why, like when we're starting from a particular node, so to that node the distance will be 0 only, right? From starting node to that node will be 0. Okay, so and then you'll have to mark this visited of source to be true. Okay, now we have taken this distance vector as size of 3. Okay, and I was like we were denoting x, y and z as column 0, 1 and 2 respectively, but here we have x value 1, 2, 3. So what I'm trying to say is we'll have to make sure if source is x, then the distance whatever we are storing, it has to go to column 0. Okay, so we'll have to check if source equals to x, so I'll update the source to 0. Like this is my column. Or we can take one more variable, let's say int column only. So your column is going to be 0. Else if your source is y, your column is 1. For distance y, we are storing in column 1. Else if it is z, then your column is 2. Now we'll do BFS traversal. We'll have to traverse until your queue is not empty. If queue is not empty, we'll have to move. Take temporary as queue dot front. The front element I'm taking. It's a typical DFS BFS traversal. So I'll take distance as d, which is going to be temp dot first. We have taken the first element. Now we'll have to remove that element. Sorry, front element. We'll have to remove it. Now next I'll take node. My node is stored in second. Now I'll have to take a for loop. Let me call neighbor node, and it has to be adjacency of node. Okay. So we'll have to check if this neighbor node is not visited, then only we'll have to insert into my queue, or else if it is already visited, which means that node we have already taken care, so we don't need to take other time. If we take other time, so it is going to be an infinite loop. So visitor of neighbor node is going to be true, and in the queue you're going to push the distance, which is d plus 1, whatever distance we have till this node, and when you are moving to the next node, its distance is d plus 1, and your neighbor node will be inserting. Okay. But you are not updating anywhere your distance value, this, so we'll have to insert the distance value as well. So now when you got this distance, right, so you can update distance of node comma the column, it is going to be d, right. So distance we are updating it here. Let's try to run it. Okay, somewhere we are missing something. Yeah, we are missing here. It has to be auto because it is a vector of vector, so it shouldn't be int. Yeah, it is running fine. Let's try to take this case as well and check it. Okay, it is getting integer overflow. The reason being is I'll tell you where it is happening here, because your n is 10 power 5, right? At max will have a distance of 10 power 5. So you're doing 10 power 5 into 10 power 5, so it is 10 power 10. So it may happen that it is going out of bound. So you'll have to make sure you do ll with long. Make sure you typecast it to long. Now let's try to run it. It is getting accepted. Let's try to submit. So yeah, it got accepted. So in this way you could have easily solved the problem. It's a typical BFS traversal, that's why they've given medium type. And yeah, you should know the how to traverse BFS, even if you don't know, like in BFS you'll have a source node. So source nodes you will be inserting, and you will explore all other nodes. From source node you will be exploring the adjacent nodes, so that we are doing at this position. Okay. And if that node is not already visited, then only you will have to push into the queue in order to make sure next time it is getting like from that node you will be moving to the other neighbor nodes. So yeah, thank you guys for watching the video.